Right, so welcome to this first Programming Interviews Easy session. What I have is a bunch of questions that I shared earlier in the day. What I want to do is essentially walk through these questions. We have about 50 minutes or so today, and we'll just use the time that we have and carry on. So folks who are actually dialed in through the phone, if you want to see the shared screen, then you will have to use the app to do that. That is one way. You can also log in on freeconferencecall.com and you should be able to see the screen share right there. Alternately, you can use the Etherpad link and the PDF that both have been posted in the meetup. So feel free to use that. I'm just using the shared screen so that we can also post the recording after this meetup. If you have any more questions, please feel free to ping on the chat. I should be able to. I'm observing. I'm watching the chat, and I'm able to provide feedback as well. All right. Excellent. So we have a bunch of folks already in the call. So why don't we get started? The first question that I have, essentially, it's a two-part question, which is given an integer, convert it to a string, and given a string, convert it to an integer. Any thoughts? Has anyone actually attempted this? Let me just tell you light in the old meeting. So yeah, anyone attempted this question at all? Can folks hear me? I just hear silence. Okay. All right. So any thoughts? Like, let's assume this is let's pretend that this is an interview. So the first question is essentially let's do ITOA, which is essentially int to string. Given an integer, how do you actually convert to string? Thoughts? Hey, this session is for folks, so for all of you. Please go ahead. What are your any ideas, any concepts, anything that you want to try?
I haven't attempted it, but I just got an idea for int to string. By the way, I'm Amrita.
Go ahead.
I think we can get each digit from the integer and then append it to form a string.
Mm-hmm. Sounds like a good plan. How do you actually get each digit?
So getting each digit, we divide the number by 10 every time and get the remainder.
Okay. And then how do you move forward? Like, how do you get the next digit, or how do you continue?
So the remainder, basically we use the mod operator. So every time the remainder is one digit in the string, and then we recursively, you can do it in like a while loop, dividing the number by 10.
Okay.
And we end when the number is 0.
Okay. Sounds few things to actually just start, right? So number one is that you're making an assumption that this is base 10, right? Okay, probably on mute, so you may not be Oh, sorry. One second. Let me make sure that I. Give me 1 minute. Let me actually just dial in from it. Just give me 1 second. Hey, I'm hoping that you guys can hear me much better now. I'm actually dialed in from a phone. Is it any better?
Yeah, it is a little better, but still there is echo.
Echo is possibly because there's somebody else who, I think, let me mute that. It should be much better now. The echo is actually coming from one of you as audience. I have muted whoever was causing that. Okay, all right. Jagruti, I think it was you who was causing the echo, unfortunately. So that's fine. I have put you on mute. If you need to speak, let me know. I'll unmute you. Okay, so let's get going. So Amrita, you were saying that you will be extracting it digit by digit, and what you'll do is you said that you will extract them and then you will concatenate, right? So first question to you when it comes to extraction is you said you'll be doing a mod with by 10 and getting it there. So one of the assumptions you've made is that the base is 10.
Yeah.
What do you do if the base is not 10?
So we can just do like whatever base the number is in. It's the same thing essentially.
Mm-hmm.
Instead of dividing
Same thing, right? You can do mod.
the bases by 2, we do it by 2.
Okay. What if the base is like 16?
16, then how do we get the digits?
Correct. So you just need to map, right? So when you do mod 16, you get a number which is between 0 to 15, right? You just need to, all the digits from 0 to 9, you just keep it as is. 10 gets mapped to A, 11 gets mapped to B, and 15 gets mapped to F, and you're good to go. And essentially what you get back is a hexadecimal number. Yeah. Right? So that works in the int to string mechanism. How do you convert, can you convert something to base 1?
I don't think it will be based on, it will be all zeros then, right?
Right, base 1 doesn't make sense. That's why if you look at the question, it actually says you can go from any base 2 to base 36, so that you can do all the letters. There's base 64, which uses the capital letters, lowercase letters, and it also uses the plus and the slash as 2 extra characters, and that's how they get to base 64. All right. So that essentially is this idea. So yes, the logic is pretty simple. You extract digit by digit and then you append. So why don't we walk through an example? So let us say that you have to convert 52 in, let's say, base 8. What do you get? What's the first thing you do?
So we first need to get the reminder divided by the base. So it's like we do 52 mod 8.
And what is that?
So it'll be 4.
Yep, it's actually 6 or 4, right? Quotient is 6, remainder is 4, correct? Okay, so then you put the 4 in the string, correct? What's the next step?
The next step, I divide it by 8, so I take, okay, it doesn't work the same way for 10 and other bases, basically.
Why? Why? Let's actually do base 10 first then. Okay? 52, go ahead. Or let me make it 152 just to make it a little bit more interesting. Go ahead. So this is essentially 15R2, right?
Yeah.
15 is the quotient, remainder is 2.
I append 2, and then I have 15 left. So we go back and do 15 by 10. It'll be like 1R5. And then I append a 5.
Okay, so now you have 2, 5. Go on.
And then we have a 1. So it'll be 0R1. And I append the 1. And basically we are looking at the reverse of this.
Correct. So what's the next step?
So the next step is, since the number is 0, we come out of it, and then we do reverse the string, reverse this, assuming like I added to a string buffer.
Okay. So you reverse and you get 152. It should work exactly the same way. Let's assume 152 is what?
So with base 8?
Yeah.
So if it is with base 8, 119 or 0. So then
you append 0.
I'm appending a 0, and I have 19 left. And then it'll be 2R3. And then 0, 3, and then it'll be 2, 0R2. So it'll be 0, 3, 2.
And what you get is you get 2, 3, 0 after you reverse it, right? That's pretty much it. That's a set of steps that you need to do. The only thing is your termination condition is when the quotient is 0, correct?
Yes.
And then you just keep extracting the remainder, and then you just keep adding it, and you're good to go. The only other piece is that the remainder will be can be any number between 0 to base minus 1. So if you have larger numbers like 16 or 25 or something like that, then it's not just the digits itself, right? You need to also go through a mapping exercise.
Yeah, if it's more than 9.
Correct. That's fantastic. Good job. Now you just have to find a way to take this and translate this to code. We won't do that here, but that's something. This is like the right approach, right construct. Any questions on Amrita's approach? All right. So this is good. Great work, Amrita. This is actually fantastic. This is the crux of the problem here. Is you got the basic elements here, which is essentially do the division, get the remainder, get the quotient. Quotient keeps continuing. The remainder gets appended, or rather prepended, as the case may be. There are multiple optimizations that you can think of. One of the optimizations is essentially to, instead of actually going through the process of finding a string and reversing it, you may be able to identify if the length of the string, and then you can start from the end, start populating it, right? So you know that 152 has to be 3 letters because it's less than it's more than 8 power 2, which is more than 64, but it's less than 8 power 3, right?
Yeah, so get the digits and start from the other end instead of reversing.
Correct. So instead of populating 3 and 2, you could populate 0, but you do it on the right hand side, and then you do 3, which is to the left of it, and 2, which is to the left of it. So there are a few different nuances that you can do, but those are just optimizations on this. It makes the algorithm a tad bit more efficient in terms of memory, if at all, and operations wise. You don't have to invert and do things like that. Okay. So good stuff. This is actually great. So let's actually take this and flip it over to the reverse, which is ATOI, right? How do you do this? Given a string which is like 230 in base 8, right? How do you convert it back to 152?
I think like we take like character by character, considering like each character is a digit or any valid character in the base that we are looking at. And we should go by the length of the string here. So it's like 2 times 8 squared, and then keep adding to that.
This is 2 times 8 squared is essentially 64. So you're saying this is 2 times 64.
2 times 64 plus 3 times 8.
3 times 8 plus.
It's actually 0
times 1, right?
Yeah.
And that is essentially 152. So this is right. This is like this is the math behind it. How do you actually how do you do that? So are you planning to extract the 2 and then multiply that with 64? Is that the approach that you would take?
So since like 230 is a string, the string length is 3. So I will go by the 64 is basically the base to the power of string length minus 1. If we are starting at 3, and then the next one will be like minus 1, like we keep decrementing it, taking the first character. So the first character is 2, and as we spoke earlier, like if there's a map for that base, we map that to the specific number in that base.
I think it's a fantastic idea. It actually works. How about trying to reverse the ITOA that you did before? Like what happens if you got the 2, right? Let's just assume it's just the 2. Just keep the 2. Okay? So if 2 is in base 8, then it's actually 2 in normal number as well, right? It's the same thing, correct?
Yes.
Now, when you did 23, all you're trying to do is you take the number that you have, multiply it with 8, and then you're just adding 3 to it. Right? What is that?
Okay, that will be 19.
That's exactly what you got earlier, right? Remember?
Yeah. It's basically the reverse of what we did.
Exactly. Then you take 19, multiply it with 8, and then you just simply add whatever the next is, 0, which essentially gives you the same 152. Right?
Yeah.
So what you're doing here is instead of multiplying anything with 64, you're just multiplying everything with 8 every step of the way. So you are multiplying with 8 3 times.
Yeah.
Which is getting to the 64 anyways, but it's just that you're doing it in a different way.
Yeah.
8 to 3 2 times, right? 64 only. So it's just 8 times 8. That's all. Right? So this is another way of looking at it. So you could have done the same approach for the earlier problem as well. For 152, you could have actually divided by 64 to have gotten the 2.
Yep.
Right? And then you could have divided by 8 with the remainder, and then you could have gotten 3. And then you could have divided by whatever is remaining by 1 and essentially kept it, which is the same number. So there are different ways of approaching ITOA, but this is what it is. Now, I think that the key challenge to note here is that, again, one of the biggest risks that you run into with ATOI is what happens if I give you like a number which is like 50 characters or 80 characters or something.
So you're taking like character by character?
Yeah. So what will happen to this number? Let's assume that this was there like 1,000,000 times for what it's worth. How do you convert this to a string or to int?
So it might not even fit in an int sometimes.
Exactly. So what you run into is the risk of integer overflow, and primarily because you're multiplying it with 8 multiple times, right?
Mm-hmm.
So as you go, at some point of time, you will discover that this is it. After this, whatever the output is large enough that it cannot fit in it anymore.
Yeah, maybe like at each step, like we could have a check to see if it's overflowing.
How will you check if a number is going to overflow? Like, how do you know that something like, how do you know if foo times 8 actually will overflow or not? You're doing n times 8 plus r, right? How do you know that n times 8 plus r will overflow?
We can just check with integer dot max value, something like that.
So can I do this? Can I say if this is greater than int dot max value, then error, something like that?
Yeah.
Are you sure? Nothing can be greater than int dot max value, right?
Since that will anyway go.
If it overflows, it will just wrap around. It will become a negative number.
Yeah, that's right.
So you can't compare something with max value, right? It doesn't make sense. But what you can do is you can do the reverse, which is like, this is just basic inequalities, right? So you can do this. Essentially max value minus r, correct? And then you can do divided by 8.
So that will definitely
This is doable. This is doable, right? N is an integer already, you know that. And you're just checking if n is actually greater than integer dot max value minus r divided by 8. If so, then when you multiply n by 8 and add r to it, that will overflow, right? Does that make sense?
Yeah, that makes sense.
And at multiple times, when I'm actually walking through interview questions and when I'm walking through basic programming constructs, one of the things that come up is like, hey, I can check if something is overflowing, and like if I add two numbers, is it overflowing, and things like that. The biggest challenge that you have is you cannot do the addition and then see if it overflows or not. It's impossible. It doesn't make sense. So what you have to do is you have to check in you have to use your basic math inequality construct and reconstruct the inequality formula so that the math works out for you. Okay.
Okay.
All right. Any questions on these two? I can move on to the next question, which is a lot bigger and a lot more interesting. So, any questions on ITOA and ATOI? This is a super basic question. I'm expecting all of you to be able to write the code for this. The logic is not very complicated, but it has a lot of edge cases, so it's not super simple either. Okay. Go ahead. I thought somebody was about to say something. Go ahead.
Yeah, Vivek, if the expectation is that we need to handle a string overflow and we don't need to put a check, so is it expectation we have to convert into a string and then print it out? So say it's a very big number and it is bound to be integer overflow. Then what we have to do? Do we need to convert to string and then print it out? Like the string manipulation need to happen?
No, it won't. It generally doesn't work, right? So if it's a pretty large number and in string and you can't convert it to the corresponding integer representation, which is what I think the risk that you run into. If it's when you say integer representation, right? You're looking at if the goal is to get it to base 10, right?
Okay.
You can do that as concatenations as well, right? You can you should be able to divide and get that. Normally the focus of the question is around, so this interview question was primarily focused around the fact that you're given numbers and you're just converting them from one base to another, and if the value is super large, then you just actually detect that it's super large and just say, hey, it's too big and can't produce an output. Don't print wrong values, is how I had it structured.
Good.
If the expectation is that you have to find the right values, then there is a lot more complexities involved. Converting an int to a string is easier because string doesn't have a finite boundary, right? You can just keep printing values over and over again. Whereas the other one is harder in the sense that if you're given a gigantic string like Achyut is asking, how do you actually figure out the value, and what happens when it overflows? At that point of time, it's impossible to figure out, because since it's base 8, you can't really say that the last number is the last number. It doesn't make sense. Every value will keep changing as you go.
Okay, because I read somewhere like we can divide by a value and still keep it within the range, and then finally convert into string and print it out. But
that is exactly what you have done, right? The base 8 is already like you have divided by 8 multiple times and you've gotten it there.
Mm-hmm.
So not technically possible. The only other way of looking at it is to use a data structure like big decimal or big number that essentially lets you store large values, and it lets you do math operations, which is not really a very useful construct.
Okay.
All right. So let's move on to the next question. So I don't know, Achit, if that answered your question. If not, please speak again, and then we can cover that as well. All right, let's move to the next question. All right, so next question is essentially, it's a pretty simple question around permutations. Permutation is essentially given an input which is like THAT. I'm expecting you to print an output that is all combinations of all the letters that you can make using the T, H, A, and T. Okay, so that's what it looks like if you're on the Etherpad. We are just looking at just this. So how do you? Any thoughts on how to actually accomplish this?
Use recursion.
You can use recursion, and how would that apply here?
So we could take the first character and like split it off, and then call our function on the substring, the remaining substring.
Mm-hmm. And how do you deal with duplicate characters?
Well, we can have like a hash function or like a hash map of the combinations we've already seen before.
Fantastic. So just a small like word of advice and caution, right, is that try not to use the properties of a set or a hash map to determine unique outputs, because you may be generating tons of combinations. For example, if the input string was 1,000,000 A's, that's it, nothing more than just A, all more, right, or just 1,000,000 letters, guess what the output can be, or what would be the output? It's just one string of the same 1,000,000 A's, right? There's no other way, there's no other permutation. Does that make sense? But if you use a hash map to figure that out, you will be generating essentially 1,000,000 factorial combinations, and you will be using the hash map or the property of the hash map to make it unique, which is a pretty bad runtime complexity, right?
Yeah.
So how would you do it otherwise? Let's pretend that hash map is not a good way of doing it. So what would be a better way of doing it? Same thing, Achyut. Hash set is the same concept.
Remove the first element and keep inserting into, run it through a for loop. Insert it into like the position right after, right? In the for loop, you have the index. So you generate new string that way. So that becomes HTAT, HATT, like that, and you keep doing for each of the characters. So you basically keep removing the each character and try to insert at the different positions. And then the final output, you can actually check if it is a duplicate or not. You can save it in a set and return that.
That's the challenge, right? If I give you a string with 1,000,000 A's.
Oh, okay. Yeah.
Then you will be generating 1,000,000 factorial combinations, and each combination will essentially be just 1,000,000 A's. They're all identical to each other. The final output should just be A. That's it, right?
Yeah, but we are checking in that case what will have the 1,000,000 A's. The first case will have 1,000,000 A's. In the second one, when you generate, we'll check if it is already present in the hash set or not.
And
so
it will get deduped. But what is the runtime complexity of this algorithm?
Yeah.
Million factorial. It's n factorial, right? As many as characters you have.
Yes.
Not a good idea, right?
Yeah.
Any thoughts?
Maybe I was just thinking if sorting would help.
Sorting might help. So let's say we start with sorting it, right? So THAT becomes AHTT. Go on.
So we sort the string and then.
It's technically not necessary, but sorting is fine. Let's go with that.
Yeah. So sort once you have it, do the loop I was mentioning only for the unique characters.
Right. And you can do that even without sorting.
Yeah.
Right.
So,
what you can do is you can take all the letters that you currently have, like all the letters THAT, and you can put that in some sort of a set, just the letters in the set, not the whole output, but just the letters in the set. So what you have is essentially THA would be in the set. There is no second T, right? So which means the only three possibilities for the first letter is either a T or a H or a A. That's it. Those are the only three possibilities. Okay. If the first letter is a T, then what is the rest of the string made of? HAT, some permutations of HAT, correct? If the first letter is H, then it's made of some permutations of TAT. And if the first letter is A, then it's actually made of THT, and that's it. Does that make sense? The only three possibilities for the first letter is either a T or a H or a A, correct? So far with me?
But doesn't this, so we need to maintain the unique letters at each pass of the recursion, right? In that case?
So
if you
what
have
will your recursive function, what will be a recursive function signature look like? So your function signature essentially will look like something like saying permute, okay? And what you're saying is string prefix, comma, that's it, right? That's all it look like. You just have an array of characters, which are the letters. So when you start, you will call this with nothing, and you'll call it with THAT. Right?
Yes.
And I'm going to put this in square bracket to indicate that it's an array. So it's T, comma H, comma A, comma T, right? That's what you have. Now, what you're doing is you don't need to, if this was sorted, right? If it was actually sorted, then you don't need to do the set thing. If it had been like sorted, then you don't have to do the set. Otherwise, you'll have to go through the process of creating a set every time. So essentially what you're doing is you're doing for each character C in this letters, if C previous character equals C, then continue. Okay, else you just set previous character is P, you just copy this, and then you're now saying that permute of instead of it being a character array, let me actually make it a collection. Okay. And that's about it. Should this not give you what you want? That's all you've done, right? So this is assuming that the list is sorted. So all it's doing is that it extracts character by character. And it'll get you A first. Since A is not equal to the previous character, it'll remove A from that list and it'll pass down. It'll continue permutation of A, comma, HTT. And then it'll add that A back here and then it'll go back. The next time it'll essentially do H, it'll pass H and it'll be ATT. And then the third round around, it'll essentially go and do AHT. The prefix will be T and the letters will be AHT. And so on. So this doesn't solve the problem yet, because what we need to do is, at some point here, what you're saying is that if letters is essentially empty, then you're done. Your prefix is the output. Right? So this is a recursive approach that will give you the answer. There's nothing in the letters, then you've used everything. That's a unique permutation. By sorting it and by actually dealing with this 64th line where if PC equals C, that continue, we are avoiding the need to construct the set every time. Questions?
So what is the PC doing?
The previous character. So it's just preventing duplicates. I will if I have already processed a T, then I will not reprocess the second T. So this will actually run the loop. When the loop runs, it will work for T, because when I'm running this for T, when I'm for the first T, then the previous character was H, right? So I will go ahead and continue the process. But once it comes out, the second time, since the last character was a T, it will not go back into the loop.
Oh.
Line 68, I am just adding it back to the letters. I am removing the thing from the letters and I'm adding it back. I'm just like returning the letters to its original state. That's all. Prefix addition happens in line 67. Okay, it's a pretty like naive solution. It kind of works. It gets the job done. You should be able to try it out. Okay. Any thoughts? Any concerns? Any questions?
And
so what do you think? How do you think the million will work for this? Go ahead. Sorry, I was interrupting you. Go ahead.
Yeah, I just wanted to ask, when we initially call this, what will letters be? Letters will be this array on line 59?
Letters will be all the individual characters in the original string, extracted and sorted.
Okay.
But who's this?
This is Hanif from...
All right. Awesome. Okay, questions? All right, so let's what happens if you do 1 million letters, right? How do you think this works? Imagine you have 1 million letters, 1 million A's, right? That one. What will happen is that the input string will be 1 million A's. You will go down this recursion tree 1 million times. You'll go recursively over and over again for 1 million times, which itself is a bad thing, because recursion generally, I think, tops out at about 500 or so. But then you'll only be generating one combination, because once you're done with that, PC is equal to C for all the other setups. So you will not be exploring all the other combinations. So it'll just go down all the way once and it'll just come back and you're done. Unfortunately, it doesn't work for a million because it's recursive, right? There is an iterative way of doing this as well, and in the iterative way, what you do is you do the same essential thing, except that what you're trying to do is that you will essentially what you do is any questions so far before we actually walk into the iterative approach, which is way superior to the recursive approach. Okay. All right. So in the iterative approach, what you do is you are given the string that you have, right? So you have T, H, A, and T. This is what you have, right? Now, essentially, what you're trying to do is at this point of time, you are here, which is essentially telling you that I haven't yet strings to my left are all they are the prefix essentially, and strings to my right are the ones that I haven't processed yet, and the current character is exactly what I'm looking at this point of time. Okay, so now what you have on the right is so essentially this is one combination. Now, in order to get a different combination, all you have to do is from the right, you will just find out all letters that you can substitute, like switch around. So you could essentially switch around H, T, A, T, and the other thing you can switch around is essentially A, H, T, T. These are two things you can get from the first string, right? Does that make sense? By just switching the T with the H or T with the A. There is no point in switching this T with the T because it's a duplicate thing. You can just ignore that. Okay. So this is what you get. Now, when you do this, what you're doing is that you actually are marking this as your recursion point, right? Okay.
So is it like
now
maintaining an index and then going from there?
Correct. So now what you can do is now at this point, your H has been fixed already. So now your next step is essentially to say that I can say H, A, T, T, and I will do H. That's it, right? H. There's no point in replacing. That's it. This is the next combination. Done. And then I will go here and try to see if I can switch the T with something else. I recognize that I can't switch anything else, so done. So far I have generated 3 combinations. These are the things I've generated.
Can you add a E to the end and see, let's finish that loop.
So let's do that, right? So let's do this. Let's start from the beginning, right? Okay. So I have THATE is what I have. Let me do THATE is what I have, right? So what's the first thing that I will do? It becomes HTATE. Then I have the other option is essentially AHTTE. The other option is EHATE, EATT, right? These are the options. Correct?
Yes.
Okay. Now let's go back to this option and then figure out what else can I do with this. Actually, no. Let's go with the first one again one more time, right? So what are the other things I can do? With T being set up, what's the next thing I can do? I can do this is AHTE, T, T, AHE, then it's T, E, A, TH. Correct? That's it. This is when character 0 was fixed. This is when character 0 and 1 was fixed. This is when character 0, 1 was fixed. Also when character 0 and 1 was fixed. But essentially I'm substituting the different characters, right? So far here. So what does this mean? T, A, how do I fix? T, He and TAETH. So this is where essentially 0, 1, 2 are fixed, 0, 1, and 2 are fixed. Now in this I need to fix the third one, which is what? TAETH is other possibility. So that's it. So far, does this make sense at this point?
Yes.
And this will become TAE is okay, and HT. And that's it. That takes care of this combination as well. And now here, these two are done. I need to now replace the A with H and E, right? So this becomes TT HAE and TT EHA. For this one, I keep TTH the same. I need to EA. That's it. For this one, I need to keep TTE the same, and this becomes AH. That's it. That takes care of these combinations. I'm going a tad bit faster, but does that make sense? Does this compute? This is the iterative approach of actually generating this. And will we generate duplicate combinations with this? Any thoughts? Maybe, maybe not. Absolutely certain we won't generate. I mean, any thoughts?
So we basically start with an index and we start swapping every other character with that, only if it's not same as the character that we're swapping with, so it won't generate any duplicates.
Correct. There is absolutely no way we'll be generating any duplicates. Correct. Right? All right. So anyway, this is this approach. Geeks for Geeks has like the code for this. You should be able to look it up if you're try to write it yourself. Now that you have the basic outline of the algorithm, I'm a little uncomfortable with what we discussed. I mean, this is the outline of the algorithm, but essentially this still sounds a little recursive at this point of time. It just is not doing the same thing that we did before, but it's still doing recursive. I am maintaining copies, so I don't like this. There is an iterative algorithm which actually just involves generating, given one combination, you're just generating the next larger combination out of that. And that just works. So,
so is it like, so we start with the first character and then, so that will be like one combination?
So let me see if I can redo the one thing in a different way. So this is what was given to us. So what I'm actually doing is let me just sort it as chi so that it becomes AEHTT. Okay. Now assuming that these are numbers, right? So this is like essentially 1, 2, 3, 4, 4, right? If you think of it this way, what do you think is the next largest number that you can make at this point of time? Given 1, 2, 3, 4, 4, what is the next largest number you can make?
4, 4, 3, 2, 1?
2, 1.
No, 4, 4, 3, 2, 1 is the largest number, right? 4, 4, 3, 2, 1 is the largest number you can make. What's the next largest number that will be? It's 1, 2, 4,
3, 4.
3, 4, right?
Yeah, 3, 4.
Okay. Now, how did you come to this? So this is exactly what this will be. So this represents AEHTT. And this represents like AEHTHT, right? What's the next largest number that's possible? 1, 2, 4?
4,
4, 3.
4, 3.
And that will represent AETTH, right?
Yeah.
And so on. So you should be able to generate the next, given any combination, you should be able to generate the next combination based on that by just making tweaks to that. And once you're able to generate that, you should be able to get the entire list. And how does that work? How do you find the next largest number?
So we start from the back and keep swapping.
So you start from the back, okay, and then your goal is to find a number that is smaller than this number, correct?
Mm-hmm.
So is 4 smaller than 3? Nope. Is 4 smaller than 3? Nope. You found this 2 that is smaller than 3, right? So essentially what you're doing is you're saying 1, 2, 1, you're swapping this 3, 4, 4, 2. Then what you need to do is you need to essentially invert this to make it 2, 4, 4. The reason for that is, think of it this way, right? Like if you ignore duplicate numbers for now. Let's assume 1, 2, 3, 4, 8, 7, 9, 8, 7, 6.
We are
2,
sorting
right?
it, right? It should be in a sorted order.
So no, at some point of time you generated this combination.
Okay.
Right? Okay. Now, what do you think is the next largest number to this?
So you swap the 1 and 2 and then reverse.
No, not yet. So first thing is you're trying to see if you should swap 2 and 6. That doesn't make sense. Then you try to see 2 and 7. That doesn't make sense. Then you try to swap 2 and 8. That doesn't make sense. Try to swap 2 and 9. That doesn't make sense. 2 and 4 doesn't make sense. 2 and 3 doesn't make sense. You're swapping 2 and 1. So 2 needs to come to the first digit. But now what you need to do is you just need to make sure that these things are in the sorted order, right? So it needs to be 1, 3, 4, 6, 7, 8, 9 would be the next largest number, right?
So
Does that make sense?
That would mean we are sorting at every step?
Not every step. So the numbers that you're actually, so essentially you're trying to find out which number is actually smaller than this to the left.
But I thought like when you swap, 1 takes the position of 2.
No, hang on. I apologize. There is a better number, right? So sorry, I missed. This is not the next bigger number. Look at this, right? 1, 3, 6.
1, 4.
1, 3, 6 is a much bigger number, right? 1, 3, 6, 2, 4, 6, 7, 8, 9, 6, whatever, say 7, 8, 9 is smaller, right? It's larger than this and smaller than this, correct?
Yes.
Okay. So yeah, so if I remember correctly, the algorithm goes like so, right? As long as the number is increasing in order, you just continue. The moment you find a number that is decreasing, which is like the 4, you identify where the 4 needs to go in this list. And I think what you see is that 6 is a number that's larger than 4. So the first thing you do is you swap the 4 and the 6. Then you invert this. 2, 4, 7, 8, 9. That's it. Which is what you got, right? 2, 4, 7, 8, 9. This is a different question, which is given a series of numbers. How do you find the next number which is formed by the same, next largest number that is formed by the same digit? That's the algorithm. You could use the same technique to generate permutations as well, because it just works exactly the same way. And as long as you're able to generate the next permutation, when do you think the permutation, there is no next permutation? When the numbers are in exact reverse order, right? In this case, it's 9, 8, 7, 6, 4, 3, 2, 1. Once you generate this, there is no next permutation to this.
Yes.
So till you reach, so from 1, 2, 3, 4, 6, 7, 8, 9, till you reach 9, 8, 7, 6, 4, 3, 2, 1, you would have generated all the combinations. So that's the process, and you can actually write that in the generate permutations combination in the same way. All right? We didn't do much code. We just did problem solving, but this was fun. But I want to make sure that we are writing code the next time we meet. Okay. So let me stop this session here, and then I'll take a few questions if need be.